Jet Propulsion Laboratory presents the Von Karman Lecture, a series of talks by engineers who are exploring our planet, our solar system, and all that lies beyond.
Hello and a very pleasant good evening to you wherever you may be. I'm Brian White from JPL's Office of Communications and Education, and welcome to the Von Karman series. Throughout our series, we've taken a deeper look not just at our missions or objects in space, but also some of the careers at JPL. Tonight, we take a deeper look at instrument operations engineers, what they do for their mission, and how they do it. In doing so, we'll be discussing a wonderful mission called MAIA. And before we get to our speaker, I'd like to introduce our questions co-host for tonight, Public Outreach Specialist Jocelyn Argueta. Hiya, Jocelyn.
Hey, Brian. Super excited for tonight's talk. And if you're watching, wherever you're watching us online, we want to remind you that this is your space program and we want you to be involved. So feel free to add your questions to the chat box and our wonderful social media team will get those to us. We'll try to answer as many of your questions as we can tonight. And if for some reason you can't see the chat box, just hit refresh and it should pop up.
Thank you very much, Jocelyn. And as a reminder, as she said, if we are in technical difficulties like I'm having right now with speaking, we ask that you do speak with us as we get those sorted out. Now, without further ado, let's meet our speaker. She is an instrument operations systems engineer here at NASA JPL. She has worked on projects from Cassini to the upcoming MAIA mission. Please welcome Janelle Wellons. Hiya, Janelle.
Hi, Brian.
Welcome. We're so excited to have you here tonight. The main thing I want to start off with, what's your origin story? All good superheroes have origin stories. How'd you get to JPL?
That is a great question. You know, my origin definitely didn't start with me thinking that I would actually end up here one day. Instead, in school, I was more concerned about learning new things, being curious. I didn't really have that path in mind. And going back specifically to junior year is when things really took a turn for me. Because looking around, everyone was thinking about things, college, what they wanted to major in, where they wanted to go to school. I mean, in my mind, I was like, oh, we have to think about those things. And so I actually started to get mail like addressed in my name to my home, which was not a normal occurrence, from colleges all over the nation. I mean, I got schools saying, look at this track program. I ran track and, oh, look, we have this great thing in literature. It was amazing, but at the same time, really overwhelming to the point where I just started taking the mail, putting it in a container and storing it underneath my bed. And when I ran out of room there, I actually just started to throw it into the trash can, which, by the way, you probably shouldn't do that. So, okay, I come home one day, I got my sack of mail, take a look at it, looks good, it's going to the bin. But on that particular day, my mom is in the kitchen and sees me walking this stack over and notices that the pamphlet on top is from a school called the Massachusetts Institute of Technology. School I had never heard of before. But apparently she had. She herself is not an engineer or a scientist, and neither is my dad. But my mom worked with engineers, and she recognized that MIT was a good school, and we needed to look at this program right now. And so we did. Put it out on the front table, looking at the program. Oh, you're going to come with other students from around the country. You're going to study math, calculus, biochemistry. You're going to do some engineering. And if you get in, it's totally free of cost. And hey, saw that. My mom's like, oh, you're filling this application out. So, okay. And I did. Night before it was due, hit the final submit button. Forgot about it till a classmate was asking a group of us, what are you going to do for the summer? And I said, oh, I'm going to run cross country. Then I remembered, oh, or I'll go to this program at a school called MIT, if you've heard of it. He's like, heard of it? Do you understand how difficult it is to get into MIT? I said, no. That night, I went home. I looked up the statistics for the first time. Over 2,000 students applied the year before, and they only let in one from the state of New Jersey, where I'm from. So clearly, it was a wrap. I'm not getting into that. I mean, I'm not even top of my class here at a high school. I mean, why would they choose me? There's so many other people who would be better. So when my mom called me that spring saying I needed to rush home, there's a package in the mail, I'm thinking, what is she? We went over this, but I got home and she's there saying, take it, take it. And I'm like, Mom, don't get your hopes up. And she's like, Janelle, do you think they sent you a package to tell you didn't get in? And whoa, something clicked for the first time. I opened that package, saw the word congratulations. I can't even tell you how exciting that moment was for me. Me going to a school like MIT, it just goes to tell you that you don't know what moment is going to be the life changer for you. For me, it was a pamphlet that my mom forced me to look at. I would have counted myself out if it weren't for her. And so that's how I began my journey and ended up at MIT.
And if not you, who? So if you bring up image 2 here, we could see you in some of your MIT splendor. Now, how do you get from MIT to JPL? We love those abbreviations here.
Oh, yes, tons of abbreviations. So I'm at MIT and I'm thinking I'm going to become a theoretical mathematician. But I start talking to my classmates and they say, try out an engineering class. And so I'm looking at the list and you got mechanical, electrical, computer, lots and lots of choices. And I really didn't know where to start. But I came across this one major called aerospace engineering. Space? I mean, I don't know about anyone else, but to me, space has always been cool, like looking up black holes and all this other stuff. So, of course, I go to Introduction to Aerospace Engineering. And I'm there on the first day. The professor's going over the syllabus. Hey, this year we're going to learn about the rocket equation. We're going to learn about how planes fly. And we're also going to learn a little bit about the history of spaceflight. And, I'm taking all this in. And he shows this image of an astronaut fixing the Hubble telescope. I mean, black background, you can see the Earth, just incredible. I'm like, wow, this is what aerospace engineers do. And then he says, oh, by the way, I'm the astronaut in that photo. What? Did I hear that right? Looking around. And, I couldn't turn it down after that. I mean, come on, this is the thing to do. And that's what I did. But you may be wondering,
Yeah. No, please.
You may be wondering then, how did I get to JPL? And really, it started in that class.
Yes, please.
And so, I continue taking all these classes, and the professors keep on giving us examples. Hey, we're going to land something on Mars, like JPL. We're going to send something to Saturn, to Jupiter, like JPL. JPL was coming up all over the place, this magical three-letter word. And I knew if I wanted to get into space exploration, JPL was the place to be. I went to the career fair every year. I signed up for the internship and I never landed it. Not once, despite trying very hard, I'll add. So senior year rolls around. It's not an internship now, it's a full-time job. And I submitted my application, and for the first time I heard back, not just from one supervisor, but 3. And I remember rushing to the interview. I wanted to get there early, ripping my skirt in the process, trying to hide it when I got in the room. But I walked out of that room after going and getting called back for further interviews with an offer to start at JPL as an instrument operations engineer. And you can show image 3. That's me.
That's you. And you're here with us tonight because you bring such intelligence and passion to everything that you do, and you're a great communicator. So let's talk about what an instrument operations engineer actually is.
Yeah, I mean, I was asking myself the same question, driving into JPL that first day, NASA JPL, the exit sign. What exactly is an instrument operations engineer? But what I learned is that we basically have one of the coolest jobs ever. I mean, okay, let's break it down, starting with the instrument part. What is an instrument? When I think about JPL missions, I like to think of, you've got these 2 essential parts. You got the spacecraft or the rover, which keeps you alive and gets you to the places that you want to go. And then you have these scientific instruments that answer all of the interesting questions that the scientists come up with. How? Why, what, when. The instruments are how we get those answers. So finishing out the rest of the name, it's my job to operate these scientific instruments when they're actually in space, which is like wild. I still can't believe I do it sometimes. But my job doesn't end there. The other half of my job is actually making sure what we plan happened. And if you can show image 6, please. I do this by looking at these pretty cool screens every morning to make sure things are going the way they should be. And I kind of like to think of it like the relationship a doctor and a patient may have. So you can imagine you're feeling sick. You come into the doctor's office, right? It's a doctor, I'm not feeling great. And so they run tests, maybe look at your blood, cholesterol. I'm not a doctor. I don't know what else there is, but I know there's stuff. So they look at this stuff and they're able to say, oh, this is the issue, or let me prescribe you medicine. For me, I'm looking at screens like this that have plots, that have values, currents, and voltages instead of blood and cholesterol. And it tells me if our instrument is operating healthily and safely. We kind of describe our robots like humans at JPL, which I love. And so to me, things get a little more interesting when, nothing seems wrong. I didn't get an alert and I didn't get called at 12 in the morning, but I'm looking at the charts. And after doing this for a while, months, years, I can tell something's not right. And that's when you put your mystery hat on and you work with others who built the instrument, who designed the instrument, and you come together and you problem solve. It's just a really, really interesting and cool environment to be in right in the now when our missions are in flight. And if they're not in flight and the project is still in development, it's my job to figure out how are we going to operate it when it gets to space.
Wonderful. I want to take a quick moment. I want to bring in some audience questions because we've covered a lot of ground already in the first 10 minutes. Jocelyn, what's happening out there in the chats?
Yeah, we have some really great questions coming in. The first one is from Ciencia News on YouTube, who asks, what is most fascinating about engineering?
Ooh, man, that's a great question. Okay. I have the perfect answer because I started JPL as an engineer and was wondering, what am I supposed to do? I'm here, now what? And I ended up getting to work on a really, really cool project called the Cassini mission, Saturn. And if you show image 7, this was the result of my work as an engineer on that project. We were able to operate cameras along with a whole suite of other instruments that let us get real images. I remember seeing this when I started at JPL and thinking, oh, this is an artist rendition, right? And when they said no, I'm like, wait a second, are you sure? I had to send it to my friends, my family, like, we're doing this right now. This is happening today. We have something at Saturn. It's just like absolutely incredible what we're able to do when you put your minds together. Being an engineer is not a solo job. It's a team job that allows us to do incredible things like capture the beauty of Saturn and its rings.
Wow, that's so amazing. And I love hearing about your origin story and how you got to JPL and get to experience this. And a follow-up to that is Mary on Twitter wants to know what inspired you to go into STEM and science in the first place?
So my mom says that as a kid, I always liked math. She's probably right. I did say that I was going to grow up to be a theoretical mathematician. So I guess that is saying something. I think I've always just been curious about how the world works. I remember when my parents bought me my first video game console and, they turned around to go do something. And when they turned back, I had already plugged it in, had the game running. And I was just fascinated. What kind of technology allows you to take a disc, put it in this machine, this black box, and you get an image on the TV and you can move a character around? I mean, to me, that was so cool. And I just wanted to know, how does it work? What is the CD doing? What is the console doing? It sparked this curiosity in me to figure out how things work. And I think that really was the groundwork for me loving STEM and continuing with STEM, even though I loved other things too, like we all do. We're multifaceted people, but I don't think I would have ever let that part of my life go, regardless of what career I ended up in.
Well, I'm glad you were getting your console to work right away. Let's talk about what's coming up. Let's talk about what you're working on right now, and let's. You are a systems engineer for MAIA. So, what specifically is MAIA, and what are you going to do with what's your job with that mission?
Yeah, so MAIA stands for the Multi-Angle Imager for Aerosols. There goes those acronyms again. And I know it could be a lot, but all the words in that acronym, they mean something about this instrument, about this mission. So multi-angle is referring to the fact that this instrument is able to point at targets on the ground at multiple different angles. And it's an imager because we're able to actually capture digital images of those targets at those different angles. And then lastly, the four aerosols describes the fact that these digital images are going to aid us in helping to characterize these very microscopic particles. I'm talking 1/50th or smaller, the width of a human hair, very, very small, that in our day-to-day life, we actually can breathe in. And these particles are so small that they can get deep within our lungs and spread to our other organs. And the reason why that's not such a great thing is because they come from a variety of sources: wildfires, factories, vehicle emissions. And, it doesn't really take a rocket scientist to know that pollution is not that great for you. In fact, it's so not great for you that it's actually something that can lead to us having and experiencing health issues, such as heart problems, respiratory illness, and, death even, which I know is a scary thing to think about, but it just shows why it's so important for us to know what's going on, to gather the information. So, MAIA, once we capture those images, so once we're out in space, we're in orbit, and we're looking at these targets at different angles, and we're taking those images, that comes back here to the ground. And with some further processing, as well as with the help of surface monitors that are here on Earth that measure air pollution at different locations all around the world, along with atmospheric composition models, we are able to, at the end of that, draw some pretty nice conclusions about the aerosols or the particulate matter that we have observed. And this information allows us to learn about how much is there, how big it is, what's the size, what is the chemical composition, because it's not just one particle type, it's often many different types. And when we can, get that data and come to those conclusions, we have scientists who are able to use that along with health records that we are getting from these different locations, those targets, same targets I was talking about before. With the health records, epidemiologists, which maybe it was a term that people didn't know so much before, but maybe know pretty well now, are able to figure out the relationship between these aerosols and health issues experienced by the people who live here. And this is what makes MAIA really a one-of-a-kind mission. It's why I'm so incredibly proud to be on it. Because with this data, and with this information, and with these studies put out into the world, people are able to make better choices about, or smarter choices about, how we regulate pollution and things of that nature. And I know that oftentimes when people think of NASA JPL, they think of things like Mars and Jupiter and sending stuff out of the solar system, which is like, that is the thing. It is cool. I got to work on stuff like that. But we also do so much for our own planet Earth. And it's so important for us humans to know the state of our home because it's the only one we have. And so I'm very much looking forward to this mission for all of those reasons.
I always think it's wonderful when we get to go, you show these beautiful pictures of Saturn, but reminding folks that when we say this is your space program, it also means our home. We get to take a good look at our home. And if you want more information about MAIA, they're going to put a link in the chat. We'll also throw a little link across the screen right now that you can go and visit that after our talk today. But I want to stick with kind of our common theme tonight and talk about what are you, as the instrument operations engineer, going to be doing with this mission in particular?
Yeah, absolutely. Maybe we can go to image 11, get some nice background for the topic. On this mission, as an instrument operations engineer, it is going to be my job to figure out how we're going to actually operate this to make it mission success in the future. And you may be thinking, like, where do you start? And I was thinking the same thing. Where do you start? And you start by defining what you need in order to get what you want. So after spending some time making requirements, coming up with a design of what we think is going to work, I'm now in this phase that's very exciting where we're building the things. We are actually testing this stuff. We get to see it for the first time. And so in this mission in particular, I am heavily focusing on the tools that me and a future instrument operator is going to be using once MAIA gets into space. And these tools are going to do everything from planning out our observations, because MAIA is going to be orbiting Earth about 15 times a day, 100 times a week. That's a lot of opportunities to look at our different targets. Los Angeles, Rome, Tel Aviv, Seoul. We have so many. You can get the full list at our website as well. And in order to figure out when we can see things and what we need to do in order to see them, what kind of pointing we need a tool to do that. And once that tool gives me that information, we can then process that into commands. And these commands are instructions for the camera, and they're not human commands. They are machine commands. So they're ones and zeros, something you and I, it would probably take us a long time to decode them ourselves, which is why these tools are so useful. And so I get these commands, we send them up, and then we do that second half of the job, making sure things are going smoothly. And on MAIA, there's quite a few ways to ensure that the mission is doing what it should be. And one of them will be actually taking a look at those digital images. We said we wanted to be observing Boston. Did we observe Boston, or are we looking at the ocean? Some things are really easy to check. And so all of that, including the training, the people, is what's going on. And if you show image 8 right now, we're actually in this phase where we're in integration and testing. So what I'm doing at the moment is I'm working on procedures, which you could kind of think as your step-by-step guide. If we wanted to, for example, power the instrument on, they're not going to say, Janelle, go power on the instrument. And I get on my computer like, I think this is good, send. Instead, we have these guides that I'm able to make by talking to other engineers who are on the team, as well as the scientists. And so I know before I do anything, I need to check to make sure the currents are looking good, the voltages are looking good. Then I can send the first command and then stop again. Let's check. Is this looking good? Is this looking good? So these procedures are great. But before we just, use them for the first time in space, we use them here in the lab while the instrument is still with us, so that we can ensure that we are as prepared as we can be once we get up there.
So as an engineer, you are the problem solver. You create the list of what to do, and you are the dreamers of dreams. You're the ones that create and make sure that this is possible, that it's one thing to send a mission up there, but without the information and the data, there's nothing to do with it.
Right. Right.
Very
and,
cool.
Of course, I'm here today representing the team, because I'm just one part of it. I'm focusing on the instrument operations, but I couldn't have done it without working with people on the flight software side of things, people working on the instrumentation, building MAIA, people working with all of our partners to make it all come together at the end of the day. And so I'm just happy to be able to share the message of what good is to come for us.
It's a wonderful mission, and you've enlightened us with a lot of what's going on with it, but I know there are a lot of questions. So let's send it back over to Jocelyn and see what they're thinking out there in the world.
Hey, yeah. So Priya on LinkedIn wants to know, is MAIA targeting specific regions or just taking random pictures?
That's a great question. MAIA is targeting specific regions. The names I threw out earlier, like Los Angeles, Boston, Rome, Seoul, those are actual targets that the scientists chose for a variety of reasons. Perhaps it's because their population is dense enough, because we're trying to do statistics on this data, so we can come back with very confident conclusions about what we are able to observe in those regions. You also can choose them because they're interesting. Maybe they experience a lot of bad pollution in that area. Also, this is a study about human health. So can we get the health records from that area? So the scientists spent a lot of time actually paring down a list. And I love going to science meetings where like, my target is important because, it's super interesting. And if you'd like to see more about the process that went into that and what the full list of current targets that we have right now, you can find that information on our site.
Awesome. So you've talked a little bit about like the complexity of the mission and how many people are involved. And Musical Wolves on YouTube asks, how long does it usually take to go from idea on the paper to actually making a scientific instrument?
That's a great question. Idea on the paper to scientific instrument. MAIA is the first project that I've ever worked on that wasn't in space before I joined the team. So I'm kind of seeing everything for the first time, and it's really my litmus test for everything else. But I asked this question, I'm answering based off of what I've seen. And I've been on this project for about 3 years. And when I first joined, MAIA was basically at the phase where all of those initial requirements of what we needed to make this a reality had been done. And now we were going to move into design. So 3 years has passed. We're in integration and test right now, and we'll be launching in a couple of years. And so to me, it's like a whirlwind, because I think last year and the year before that, and I can remember when these things were just ideas. And when I went into the lab for the first time and I actually got to see part of MAIA in the vacuum chamber for a test, I got to see it move. I got to see us command it. It was such a magical moment to see it come together. Something that I had just been imagining in my head conceptually was now physically materializing. Did I say that right? You know what I meant. And so, it's a whirlwind, and it depends on the mission that you're doing. MAIA is simply just the instrument itself. But I'm sure that there are others out there who can give their thoughts on that too, since we do such a wide variety of things at JPL.
Awesome. And going back to a little bit more on the specifics of MAIA, Deborah on Facebook asks, will the imager provide close to real-time data on particulates in our atmosphere? Is it pure data? And will it be tied to every country's thresholds?
I'm not sure if I understand the full question, but I'm going to try and answer as best as I can. So when you say real-time data, I'm like kind of glad you said that, because this is like my area. So because this is a mission that is orbiting our own planet, it's very close. Compared to, the mission Cassini at Saturn I mentioned earlier, when we sent commands there, it could take an hour and a half for the commands just to reach the instrument, then another hour and a half for us to know that it got there. Very different. With MAIA, we actually do have the capability to command it in near real time. When it comes to I'm not exactly sure what you're imagining, but if you are meaning, do we send the command and on the ground we see the images right away? It's not that fast. It's not quite that fast. We plan our activities for about a week long. And then throughout that week, we gradually get data every time we have the opportunity to send it back to an antenna that's here on Earth. And then after some processing, because what we get back is raw data in those images, after some processing, then we can get to the point where we've got something to look at, as well as other kinds of data that the scientists will be using as well. And so I hope that answered your question, or at least part of it.
Yeah, definitely. I think that provides a lot of insight. And as you've mentioned, there's a big team behind this mission. And James Williams on YouTube wants to know, what's your opinion about the importance of working on a team when you're an engineer?
There's nothing that compares to it. I love to show image 5, please. This is an image of one of the teams that I worked on. the Cassini mission in the top left, you've got the people who basically trained me to be an instrument ops engineer. And I never would have been able to bring that skill and knowledge to MAIA without them being there. And think about it now. Oh, actually, let's show image 14 as well, talking about teams. I mean, teams are not just the people who work with you immediately on your projects. Teams are about everyone around you. JPL is a place that's full with people who have amazing ideas. And even though your work may never have you crossing paths, it doesn't mean that you don't get to meet each other. And this is my MIT team at JPL, first arriving and wondering, wow, what's going on here? This is all very new. I had a team, supporters, people I could reach out to. You know, I've never written this kind of document before. Have any of you? And same thing with an employee resource group that I helped to revitalize at JPL called the Black Employee Resource Group. Sorry, Black Excellent Strategic Team. How can I mess that up? I'm the president. And so, you know, that's a photo of us coming together to build this inclusiveness that shows that it's the people that make the missions great. We are the ones, the force behind these incredible ideas and daring mighty things.
So we've got time for one last question, Jocelyn.
Great. I think we have a great question looking to the future and future teams that will build other instruments. Amy Zoll on YouTube wants to know, I'm a high school student who's passionate about aerospace engineering. What advice do you have on next steps for someone like me?
You are already ahead of the game. Kudos to you. I didn't even know what aerospace engineering was when I was in your shoes. Now that you've got that goal in mind, to me, the most important thing for you to do at this point is don't be your worst enemy. It is so easy for us to be the downers. You know, we go into this application thinking, well, I know they're not going to choose me. Like, I'm not getting in, or I might as well not even try. It's so easy to feel that way about yourself. I mean, I would know. I kind of went through that before this talk right here. I'm an engineer, but I don't think of myself as an expert. I think of myself as a person who still has lots and lots to learn. And so as long as you never stop being your best advocate, in other words, you have to be confident enough to make it reality. I can't go around telling people that they can do it if I don't believe it myself. So as long as you have that mentality, it's more important than you'd ever imagine. A lot of people think the grades and the numbers are what's most important, but at the end of the day, it's what kind of person you are. Being your best self, believing in yourself, having that confidence, never letting go of your dreams, that is absolutely key if you want to get into a field like this.
Every time I talk to you, Janelle, I feel more inspired to go out there and do the thing. That's all the time that we have for questions. But before we go, I just want to check in and see if there's any last words that was pretty good right there. But any last words that you want the audience, everybody watching at home, to walk away with today?
You know, I guess if there were any last thoughts, especially on a talk right here that's all about MAIA, multi-angle imager for aerosols, it just goes to show that, you know, we as people, we have to come together in order to bring about good change. And this mission is the example of that. I absolutely can't wait to be able to say, look at what we've done and look at what we can do for the world. When MAIA's out there orbiting, making these observations, these papers start coming out. I mean, it really doesn't get better than that. Doing something that benefits humanity. And even though we all may not have the opportunity to work on MAIA right now, I do strongly believe that we all have the capability to do good. And so if you leave with anything, it's that.
And that is all the time that we have for tonight. But please join us next month for our talk, The Warm Glow of the Cool Universe, with Dita Markovic and Phil Korngut. Remember, folks, that all of our past Von Karman talks are available online, and I would like to thank our terrific speaker, Janelle Wellons, for taking the time to join us tonight. I also want to thank our co-host Jocelyn and Argueta and everyone behind the scenes that make these talks possible. And the last thank you always goes out to all of you watching at home. This is your space program, and we're so happy that you join us every single month. So please join us in October. Stay safe, stay kind, and stay curious.